and I did this talk in the same meetup for maybe 2 times or 1 time. I kind of forgot. But this time I'm going to bring some new updates about Apache Submarine. So which is, we position this to be a unified machine learning platform, open source, and we want to help more people to use machine learning easily. So my name is Wanda Tian, and I'm currently an engineering manager at Cloudera, and I'm an open source members for some projects, Submarine, Hadoop, Unicorn, and also I'm ASF member. So this is agenda today. So first I'm going to talk about the machine learning in production and the requirements, and some brief introduction about Apache Submarine, features of Submarine, and community and release plans. So let's look at the machine learning in production. So if you look at a lot of tutorials online, which you can find, they are quite simple. You just import some library and you run this in your own notebook, and you can get the results, and you feel like it's some good achievement. So there are lots of videos you can find, like handwritten character image classifier in 40 lines, image classifier in 30 lines, start predictor in 40 lines, and so on and so forth. So I think this is a good start to understand and try machine learning. But for companies who which wants to enter the machine learning field and want to get some more values from machine learning, these tutorials are kind of oversimplified. So I think many people show this graph, so I don't have to explain this anymore. But I think one thing I'm very interested about is, if you look at, there are so many technologies, so many components we have to take care to make some machine learning into production. So how we can more efficiently help the data scientists or machine learning engineers to easily write, only focus on their machine learning code instead of focus on all these infrastructures, right? Because it is pretty hard to learning all this, even a small portion of this and these components by a small team. So we have to making sure simplify all the infrastructure work and allow them to focus on the machine learning only. So this is this is a very typical data pipeline for machine learning. So the data comes from edge, and they or come from other places like browser click log, and they all landed to a data lake. And machine learning engineers, they can use notebook to do data exploration, and after that they will starting to build machine learning pipelines. They will use some ETL tools, Spark, Hive, or other cloud provided ETL tools to do the things like join, sampling, feature extraction, and split the training and test the data set. And after that, they're going to feed this data into model training. So model training will be used, will use TensorFlow or PyTorch or some other softwares to do the training. And once the training is done, they're going to save the model, they're going to version the model, and they're going to deploy the model to some online services. So this is a loop. So machine learning engineer have to repeatedly to explore the data and to do the ETL and to do the machine learning training. And also they have to verify if the model works and go back the loop again. So when talking about data scientists, we have talked to a lot of data scientists, and we're trying to understand what is the pain, and what is their need. So I'm going to quickly talk about this part. So for the data scientists, they are expert of machine learning algorithms and models. They know a different new models, how to use different machine learning libraries, and also they are typically expert of feature engineering. They need tools and platform to gain insight of the data. They will build models more efficiently, and they will create machine learning pipeline, which consists of ETL, data labeling, transformation, model training, etc., etc. And also they are most familiar with Python, Spark, and some data engineers they familiar with Hive or some SQL to do the ETL like that. So one thing was to note that they are not familiar with platform stuffs, or at least a lot of machine learning data scientists, they are not familiar with them. So what is their expectation? So for the model exploration, they will use Spark, Hive, or other alternatives to do the pre-processing, and they will first try to get some smaller chunk of data to do the experiment. They will run some smaller scale training and see the result. And after that, when they got more confident, they will train with a larger experiments using some more data to do the training. And one important thing to note is they want to make the experiment can be more reproducible. They want to record the parameters, code, and metrics of the experiment. So a lot of machine learning engineers, they just have some local code. Sometimes they don't even push this to GitHub. So they will on demand to change something in the code and run this model building again, model training again, to see how it works. So because of this bad practices, it is very hard to track in why they can get some result back. So we want to improve this part. And the second part is the dependency management. They really want to do the code once and run everywhere. So Docker and some other tools like Conda, they can help data scientists to do this job much more easier. However, to use Docker or Conda, some data scientists are still not very easy to use, especially if you want to ask somebody to write a Docker file and to build and change it when needed. A lot of them are actually not very comfortable with doing that. And also, they need to easier to fine tune parameters. They want to do things like AutoML to do the fine tune parameters. Regarding model management, they want to easily manage model and push to production. They want to do the model assurance, monitoring, etc. to gain confidence and make the result can be more as planned, can be better as planned. Sorry. Yeah, so what they don't expect to know. So first is because in many production system, it is not simply like running every machine learning model in a single machine. They have to interact with distributed resource management like YARN, many for on-prem, and Kubernetes, which is everywhere. So if we want to get to teach data scientists to fully understand how scheduler works in YARN or in Kubernetes, or how to do some operational work, like create namespaces to proper to create volumes and set up RBAC. A lot of them are found trouble to do that. So we want to simplify the platform to not necessarily to let data scientists to understand this resource management pieces. And second part is there are a lot of compute engines like TensorFlow or Spark, and they requires a lot of memory configuration and also a lot of tooling, like how to better to do the shuffling for Spark. This kind of things are interesting for infra or big data engineers, but for data scientists, they tend to not look at this. They just want to make things work. And also any other things, nitty-gritty details of underlying infra, we should just make the infra to work. So what is Apache Submarine and how we can help to solve the problem? So a little bit background about Apache Submarine. So because I started to working on Hadoop since 2011, so it's about almost 10 years. So I think I'm quite familiar with big data spaces. So initially, we see a lot of customers, they have large Hadoop cluster runs Yarn. So they want to build their machine learning module on top of that. So we started the Submarine project, which was part of Hadoop at the beginning. So we allow people to run TensorFlow or PyTorch or these applications on Yarn. And actually, there are a lot of users are interested in that. They happily deploy Submarine in their production environment, and we got quite a few production use cases in some pretty good scale. However, we look at this part and we think the machine learning engineers, they actually should not care about where is the platform to run. And we see the trend, which a lot of compute is starting to move to cloud and move to Kubernetes. Especially for machine learning, it's moving very fast. So then we want to say, hey, because we see so many needs, wants to have a better, easier to use machine learning platform. So why we not expand the Submarine to make this to be a one platform to which we allow data scientists to create some end-to-end machine learning workflow on top of this project. So then we spin off this project from Hadoop to a separate Apache project. So now it is a top-level project of Apache. And we target to make Submarine can allow data engineers, data scientists to do the data pipeline creation, model training, tooling, and push model to production. So they can be all done within this one platform. So there are a lot of things we haven't done yet. So it is still work in progress. I'm going to talk about what we have done and what is roadmap for this project. So what Submarine can do? So first is we can very easily to install Submarine on an existing Kubernetes, no matter it is on cloud or on-prem. One single command, we can install Submarine on Kubernetes. And we have experiment support. We have a Python SDK too easy to submit and manage experiments. And we now support PyTorch and TensorFlow. We have managed Jupyter Notebook service, which allow multi-users to share the same environment and share the same computer resources. Also, we have the environment, profile, and code concept to allow users to easily manage Docker and Conda environment. So they don't have to create anything by themselves. If we have some common Docker and Conda environments, they can be shared across the team. Also, we want to expand to do the model and metrics management. So there are some more design and brainstorming in the community. So we want to, so this is something we want to take up next. So I'm going to talk about all the details of these items. So there are some features of Submarine which just deep diving what I just shared. For easy install, it's like you install any other applications on Kubernetes. You just use one single command, and the Submarine server will up and running. and all the jobs can be launched in the same Kubernetes cluster. Yeah, so this is already available in the last release. We are doing the Submarine load boot support, which will allow multiple users to launch Jupyter Notebook instance in the same cluster. They can choose different environment profiles like Dr. Conda when launched the notebook instances. And when launched, user can also easily access the launched instance on the Submarine UI. So this is under development, which we target to release in the next release. Yeah, and this is experiment training support. We have Python SDK to allow you to easily run this experiment from your notebook and from your CI/CD pipeline or from your command line. So it is pretty simple. You import Submarine library and you create the experiment, and you specify an environment profile to use, which includes what is the Docker image and what is the Conda image. And inside that, you may want to localize some code, and you specify the name of the experiment and the parameter. You call it run, and this can be run, and later on you can go to the web UI to query the status of the experiment. This is already available. And there's one common pain we see from users we talk to is they really like to run some offline experiment, except they really found troubles to handle pass the code into training, and also they don't want to handle the dependencies like what is a Docker image or Conda image to use to run the training job, and where to run and how much resource to use. So they are quite struggle to understand this. So we introduced the predefined template concept, which the model engineers, they can build a common model. A group of engineers in the company, they define some predefined parameters like where is the training data, where is the validated data, and where is the output goes to. And there are a bunch of training parameters the user can tune when they're actually training the job. So when the data scientist, they don't have to understand all the details about where the code of the training job, which is a deep FM CTR, for example. They just can pass these parameters in, and this job can train in the cluster, and also the metrics will be aggregated, can be viewed easily during the training and after the training. So this is a UI for the experiment. User can say what is the experiment name, experiment ID, and the status experiment after the training, or during the training. They can query the log as well. So we also have the Git repository integration. So when the experiment is submitted to Kubernetes or other training platform, how we manage the code. So there are several options. The first option is there are some engineers, they're starting to patch the code into a Docker image. So the downside is it is pretty difficult for data scientists to build Docker image. And also this increase overhead of Docker images, because it will easily cause a lot of duplicated Docker images in the Docker repo, and it could host the Docker repository easily. And the other option is to mount a volume to a job when the job is launched. So the downside is it is very hard to track back changes on the disk and what is a version of the code. So what we have built now is to support download code from Git when the job is launched. So when the job is launched, the Submarine will clone the code from the Git repository and put this to the /code directory of the launched job. So when you write your experiment, you can put you can link the training script in the downloaded repository. So you don't have to worry about the versions like that. And also a good thing of this is we can record what is the hash code of the Git repo. So you can always trace back to what is the version of the code being running in the cluster. So this will be available in the next release. Environment profile support. So like I just mentioned, everybody likes the simplicity of the environment profile, like the Docker or Conda. However, there are less people enjoy to build and manage their Docker image or Conda kernels. It is pretty labor-intensive work, and also it will easily cause a lot of issues if, for example, if there is some build failure of the Docker build. It is very hard to troubleshooting if you don't have some deep understanding of how these things work. So ideally, we should have the environment profile can be shared between the team members so they can customize their own image and Conda kernels. So Submarine provided environment profile as a first-class concept, which can be defined, can be shared across team members, and also can be customized to any user. If they have any needs to add a few more dependencies to the environment, they can add these dependencies to the environment. Also, this can be used in both notebook sessions and also experiment job. They can refer to the environment profile, which is best suitable for the notebook or environment. So they can use the Python API to create the environment, just to specify a name, a Docker image, and also what is the Conda dependencies. This can create an environment which can be listed, can be retrieved later. And when you run an experiment or run a notebook, you just simply specify what is the environment name. So Submarine, when they launch the experiment in the cluster, they will know which Docker image to pull and what Conda dependencies to import before launch the script. So this will be available in the next release, and the feature is already merged. Yeah, so this is a UI to list the environment. You specify an environment ID, Docker image, and kernel name, and bunch of Conda dependencies. Yeah, so you can list all the available environments which we can use them. And also you can go to the detail of the environment. The community is currently working on add the environment directly from UI, but that work is still work in progress. So you might ask, what is the relationship with other open source projects, right? Because I mean, reinvent the wheel, probably interesting to engineers, but it is not fun to outsiders. So we are not trying to reinvent of wheels, and we are trying to leverage other open source projects as much as we can. So for the environment profile management, we use Docker and Conda to do this management. And for notebook, we use Jupyter. And when the experiment is running on Yarn, we use Tony project and TensorFlow on Yarn project from LinkedIn. And when we run the experiment on Kubernetes, we use TF job and TensorFlow and also PyTorch job from TensorFlow and Kubeflow. So the core value we want to create is to make the data scientists they can operate on a more streamlined and more easier to use APIs platform instead of focus on the underlying project. So regarding Submarine community, So it is a pretty diversified community and it is faster growing. We have committer and contributors from LinkedIn, Facebook, Cloudera, Alibaba, NetEase, and many other companies. So we also have lots of researchers from university have interest in contributing ideas and code into the project. Now we have 36 contributors, and which grew from 18 at the beginning of the year. So it is still a pretty early phase of the project. I would like, but we want to make all the things can be open sourced, and we want to attract more people to use this and to contribute to this project. So there's a lot of help needed. So regarding the release, we just finished 0.4 release in the July this year. So which will support deploy Submarine on Kubernetes and run TensorFlow and PyTorch on Kubernetes. So the ongoing one will be 0.5, which we are shooting for September to October. And for the things like notebook, environment profile, a bunch of UI work, etc., etc. And for the next release, 0.6, we are looking at the beginning of 2021, which we want to focus on the security and some development enhancement to make these things can be running more stable and more reliable for the production workloads. So there are a bunch of community companies are already using this. Yeah, so one company I forgot to add. So let me just touch through. So NetEase is using Submarine on Yarn running in 240 GPU nodes, and they are actually building one of the largest music recommendation engine, which is invoked 1 billion per day because there are many users of the NetEase music. LinkedIn is running in a similar scale. They're running 500 TensorFlow trainings a day, and they serve applications like recommendation system and NLP. So they are helping us to in the runtime and the SDK development. And there's a Cont, so it is one of the largest online real estate brokerage website in China. So it's similar to Redfin in China. So they're running a 50 GPU machine and also on Yarn. And yeah, so as you can see, there are a lot of users already using Submarine on Yarn to solve their needs. But now we are trying to make them like one platform to deploy everything on Kubernetes and help them to do all the work directly from Submarine instead of looking at too many pieces. So that is the goal of the direction. Yeah, so thanks for this talk. This is a website, GitHub link. So any questions?
Thank you, Wanda. I think there's one question actually is just asking whether the recording will be shared. Yes, the recording will be shared on the meetup page. So look in the comments. There's no other question at the moment. Let me ask you a question. What are you presenting here? As you said, as you were using Kubeflow and all the others. So one question is people were asking, so why can't I just directly using Kubeflow itself? Why have to use the Apache Submarine? And it's
so this is a great question, and this is something we also hear lots of feedbacks from users about Kubeflow. So basically, Kubeflow is a pretty nice platform to allow user to run the training job on Kubernetes. But the downside is it unfortunately have lots of Kubernetes concept leaked into the design of other things. Like in the API, you have to understand Kubernetes concept, and in the how to build a Docker image, you have to understand how the Docker and Kubernetes work. It is not easy for a data scientist. Let's say they want to open a notebook, they want to open a Python SDK, and they just want to run the training job, the TensorFlow or PyTorch training job directly from the notebook, and without any understanding of Kubernetes. Right? So it is still very hard to understand this concept. So which we want to make the API and also the operations can be more streamlined. So I'm not sure if Chester or others, if you got any chance to use Kubeflow in production. So what is your feedback for that?
Yeah, we haven't really used that yet, but that to my another question. So there's another open source framework called MLflow from Databricks. We're actually experimenting on that and POC on that. So that is actually a similar function on the experimentation. So people say, when a question to you, then say how that compared to Apache Submarine. So
yeah. So this is also interesting. So I think for MLflow, the biggest strength is about the metrics recording, right? So when you run the training job, you can very good to trace back what is the metrics, and there's a nice UI. You can view the if I change this parameter and how the training should look like and things like that. So we have plans to integrate to MLflow for the metrics part. However, the metrics, even they want to do the whole full-blown platform to do the end-to-end life cycle of the machine learning, but the model training is one piece is missing, which you at least that's, I actually the MLflow a few months back, you still very hard to submit let's say a TensorFlow job or PyTorch job directly from MLflow API, and you can then get the result from the MLflow UI. So that I don't think that one is available today. I'm not sure what's the plan of the community, but I think from our view, we want to leverage MLflow to be more like metrics tracking, and also the metrics recording part. It has a very nice API for that.
I see. So since nobody asking questions, let me ask one more on this topic, experimentation. Yeah. So, okay, so we talked about the two frameworks, Kubeflow and MLflow, compared to this. And what if people from data scientists say, I'm just going to use some commercial stuff, like for example, weights and biases and all the other, experimentations. I can, use their, weights and biases API and just log them, and then they can compare, the model for me, and they have, a lot of really nice deep learnings, comparison, all that stuff. So what do you comment on that?
Yeah, so I think this is also a great question. So there's so many available commercial softwares, and actually a lot of them are great. That's the Azure ML, Databricks, H2O, and there are a whole bunch of others. So I think one interesting thing I found is every software they trying to be more complete, which way allow one platform, one-stop software for everything in the machine learning life cycle. So that means each software, they will introduce some different APIs, introduce some different some different concept. For example, how to define the code dependency is different between Databricks, between Azure ML, and between Google ML. So they're quite different. So that means if as an engineer, if they want to learn something and wants to apply this in the work, they have to learn a platform if the platform is new to them, right? So what we are trying to build is pretty open source project, which we want to make the community to be more diversified, and we can make the API also to be standard. So we can allow the people to use this platform without worrying too much about what is the implementation behind that. So if they, let's say, change from company A to company B, or if they just want to do some work in their own time, they can use the same software to do all this work, right? But also on the other side, it is very hard to compete with other commercial softwares because they have money, they have lots of engineers to do. So yeah, I think this is a pros and cons, but we're trying to make the technology in the machine learning can be more standardized, especially for the infra part. So that is the goal for this project.
Yeah, it's actually very interesting because frankly, there's a lot of frameworks in this, like a one framework for all type of different open sources. I mean, from Airbnb's the big head, and Google's TFX, and Netflix has the Metaflow, and so there's a many of them, and coming in this area. So for the better.
Yeah. So I think we can definitely expect more and more projects go into this space. But I think one thing is there's not yet some dominant open source software which allow people to do and allow data scientists to do most of their production machine learning operations in a single platform yet. So this is something we want to see if we can grow this project to the next phase and can allow people to do more production workload in the open source API and open source project.
Okay, great. So anybody has any other questions?
Yeah, so I see there's one question from Xiaowei. The question is, does a submarine support run of DAG as an experiment? So yeah, so that's a good question. So we have think about this for quite some time. So far we don't support this for now, but from our design, this is part of our design, which we think it is quite normal for a machine learning training job, which requires some data process pre-process in the ETL workflow, and to do some feature engineering, and then goes to the model training and push the model to the A/B testing and things like that. So yeah, so I think this is on our list, but we may not be able to come to this one